Yes, class. Good evening. Is this audible? Fatima, Hamza, Hiba, Huzaifa, and who is there? Krishna.
Good evening, ma'am.
So in the last class, we had completed what? We had completed with the whole Ampere circuital law. So Ampere circuital law was over. And in Ampere circuital law, we had seen that the two cases, one was solenoid, other one was toroid. So in case of solenoid, we had seen that both of them, even the toroid one and even the solenoid, both of them have the same formula. And the formula for both of it is V is equal to mu naught Ni. Difference lies in the value of N. N is basically what? In case of solenoid, N is number of turns per unit length, and length becomes the actual length of the solenoid. In case of a toroid, you have number of turns per unit length, but since it's in the circular form, so in case of circular form, it becomes 2 pi r. So that becomes N is equal to 2 pi r. So these were the two formula that we had seen, and now we have to start with magnetic Lorentz force. See, before starting with magnetic Lorentz force, first we'll discuss what is the path of a charged particle when it is kept under the influence of magnetic field. If you know the path of the charged particle when it is kept under magnetic field, whichever path will it be following, then you will be able to understand Lorentz force. But before understanding Lorentz force, you have one more force to study. See, let's supposedly say these are the magnetic field lines. So magnetic field is in this direction, let's say. And let's take a charge. Q charge has been taken. So magnetic Lorentz force direction, you will have to calculate the direction of magnetic force that will be exerted when the charge moves. Also, you will have to find out the magnitude. So the way you have been taking out and using your right hand rule, because as I've told you, we'll be only using our right hand. We'll be just modifying it for different cases, for different formula. Otherwise, we'll be only using our right hand. So let's say this is the charge is moving with some velocity v, and the angle that has been made between velocity and the magnetic field, basically the motion of the charge and the magnetic field, this is what? Theta. So understand theta carefully. Theta is what? Theta I have taken as angle between the velocity component, means the direction of motion of the charged particle, and the magnetic field. This is the direction, and the angle between them is theta. I'll write down also these things. So charge Q, this charge small q, this is moving so what did I write? Charge Q is moving with velocity v. This is the velocity v in uniform magnetic field. Magnetic field is uniform, as you can see, the parallel lines. So in uniform magnetic field, that I have taken as what? B. This is B. B is the magnetic. Now the magnitude of the magnetic force, direction I'll tell you. After this, I'll tell you how to take out the direction. You will be able to do it. We'll see lots of cases for it. So magnetic force will be equal to, take the charge and write the cross product of velocity and magnetic field. This means V cross B. Charge multiplied by V cross B. This is the magnetic force. Lorentz force we'll see in the next class. We'll see Lorentz force. That is also a small topic. Just addition of electric field occurs. So electric field will occur. How that will occur, we'll see. Right now, just focus on the path of the charge particle, because if you know how to perform this, how to trace the path of the charged particle when it is kept under magnetic field, and you will be able to find out the Lorentz forces, because formula based things you will be able to do. Direction becomes difficult, and most of the times, as you people have also told me many times, that you have by mistake used your left hand and the direction is not coming out. So in today's class, we'll be practicing lots of things. So just tell me one thing, class. If it is V cross V, so will it be, when if I open the cross product, will it be VB cos theta or it will be VB sin theta? Which trigonometric component? Sin theta. Whenever we have dot product, means had it been V dot B, the way you have worked done as F dot S, force dot displacement. So what do you write? F S cos theta. Here in this case we have the magnetic force, and magnetic force, there is the cross product. Remember in torque also we did it, P cross E, that meant P E sin theta. So here also Q V cross B is there, so magnitude of V, magnitude of B, and sin theta will come. So FB becomes what? FB becomes Q V B sin theta. Theta is what? Theta is again the angle between velocity and the magnetic field. Now, this we'll be seeing. Okay, one more thing. If somehow your charge is moving in the same direction as that of magnetic field, we'll do that separately also in today's class. But if the velocity, if the charge is moving along the direction of magnetic field, so what will happen? Basically, velocity will also be in this direction. Magnetic field is in this direction. Charge is also moving in this direction. It means velocity is moving in the same direction as that of magnetic field. So angle between P, that is magnetic field, and V here becomes 0. So in such cases, FV becomes QVB sin theta becomes 0 degree, that is. Now, apart from this, few more things let us discuss, and you can note down all these things. So this formula, remember, QVB sin theta. We'll be just focusing on the how to calculate the direction, but let us first just see one more theoretical topic. How do theoretical questions come? Numericals, we'll see how to use this F is equal to QVB, how to apply it in the questions, that all we'll see. We have a full case on this. Different cases are there based on this formula. So we have full cases on this. Now, theoretical questions come in this manner, that if your force is perpendicular to velocity, can anyone tell from the class, if force is perpendicular to velocity, what will be the angle between force and displacement? Angle between force and velocity, both are perpendicular. Force is actually perpendicular to velocity. What will be the angle between force and displacement? No, double of it was F1. It will be 90 degrees. Reason is that with the rate, which velocity is basically what? Rate of change of displacement. It means if force is perpendicular to velocity, then force is also perpendicular to displacement. And if force becomes perpendicular to displacement, see what will be the work done. Right now I had told you that this is Fs, and when we have dot product, we write it as Fs cos theta. Theta here becomes 90 degree. So this becomes Fs cos 90 degree, that is 0. So it means what? Work done, if your force is perpendicular to velocity, then work done on the charge or work done by the charge, that becomes 0. So this theoretical question can also come. Work done by, basically work done by magnetic force. I'll write it down also. From this you can conclude that work done by magnetic force is 0. This is shown by this calculation. Now, in your 11th standard, you have a theorem known as work energy theorem. Anybody who remembers it, work energy theorem? I think in your this lesson, in work energy and power, you have work energy theorem. No one? Okay, it was related to kinetic energy. Now you people can think. See, work energy theorem is what? I'll just repeat it. I'll repeat it in short because we just have to see the theoretical questions that can come from this topic. So, work energy theorem. Work energy theorem basically says that whatever is the work done, this is equal to the change in kinetic energy. This is your work energy theorem. For those who are able to recall, you can revise it, and for those who are not aware of this, learn it right now. Work done is equal to change in kinetic energy. Now back to our topic. What was our topic? Force was perpendicular to velocity. This was the condition. No, all the questions will come from here. If this condition is given, then all of these questions, possibility of all of these questions coming in the exam becomes more. So if force is perpendicular to velocity, work done is zero. If work done is zero means change in kinetic energy is zero. Change in kinetic energy means what? Whenever you're calculating the change, it means final minus initial. So here you can say kinetic energy final minus kinetic energy initial is equal to zero, which says final kinetic energy is equal to the initial kinetic energy. So again, from this statement only, if force is perpendicular to velocity, then there is no change in kinetic energy. This can also come in your theoretical question. And one more thing that can come. So this you can conclude, therefore, no change in kinetic energy. No change in kinetic energy. One more conclusion you can see. See, how is kinetic energy related to velocity? Can we relate it to velocity, kinetic energies?
K is equal to half mv square.
K is equal to half m square. Yes, right. So this becomes half m v final square becomes equal to half m v initial square. So half m cancel, square also gets cancelled. It means neither there is change in kinetic energy, and actually since there is no change in kinetic energy, that's why there is no change in velocity. No change in velocity. And both of these are why? Due to magnetic field. Magnetic force. Sorry. These are due to magnetic force. So what all questions can come from your only this statement? F is perpendicular to velocity. Magnetic force we have calculated. Magnetic force is qv cross v. That means qvb sine theta. So everything depends on angle between velocity and magnetic field. If your force is somehow perpendicular to velocity, this was the condition that we had seen. This is one of the theoretical questions that can come. So if force is perpendicular to velocity, it means force is perpendicular to displacement. Work done becomes zero. Therefore, change in kinetic energy becomes zero and kinetic energy remains constant. So no effect on kinetic energy, no effect on velocity due to magnetic force. So these are few conclusions, and numericals do not come from this because this is a part of your 11th class. But theoretical questions can come from here. This is important. This formula is important. FB is equal to QVB sine theta. All right, noted.
कुछ तो नहीं हुआ बट खत्म रहेगी लास्ट लाइन।
See, basically, in this formula, we'll be seeing 4 cases. And out of them, first, second case, I'll discuss it right now, then you can copy it down. First 2 cases, those are very easy. That you people already know. The third case, we have to do it in detail. And question comes from third case only, the numerical portion. Numericals do not come from the first case, second case. Theoretical questions can come from the fourth case. So 4 cases we'll see. So first, second case, let us discuss. First, second case. Cases are very easy. So case 1 says what? So I hope you all have completed by now. If anyone is writing, just let me know. Or all those who have joined late can also tell me. I'll just scroll up if you want to copy anything. See, if magnetic field is there, let's say in this direction, right hand side, I'm taking magnetic field is there. Now, charge is being kept and velocity is in the same direction. So what is the angle between the magnetic field and the velocity right now in this case? We have discussed this also.
0.
0. Yes, question. It will be 0. Yes, Fatma. So in this case, theta becomes what? This is equal to 0 degree. So FB is what? QVB sine 0 degrees. That becomes 0. So directly your force will be 0. So theoretical question can come that if magnetic field and velocity both are parallel to each other, or the question can come in this language, like if the charge is moving in the same direction as that of magnetic field. This is also the language that can be used. Meaning is same, that angle basically between V and T is 0. Now case number 2. Case number 2 is also very easy. Case second basically says that if this is the charged particle, this is velocity. Fatima, now tell the angle for this case also. You've told it for correctly for the first part. For the second case, what will be the angle? This is the magnetic. Angle will be 180. Yes, right. Theta is 180 degrees. Hanifa, can you tell the magnetic force? QVB sine theta is the formula. Everything is written in front of you, like the first part, case 1 we did. What will be the magnetic force for 180 degree? Hanifa, can you try?
I don't know. I'm not sure.
See, do you know what is sine 180 degree? Sine 180 degree is basically, that would have been, Fatima, had it been cos. Cos 180 is minus 1. Sine 180 is 0.
Yeah.
All right. So this also becomes 0. So in these 2 cases, you don't have any magnetic force. So note down the 2 cases. We'll see case 3. And case 3, we have to do it in detail. And there we'll be having the direction also. So note these down and write I'll write the heading. This is the case for if particle basically means charged particle, is anti-parallel to magnetic field This is the case if charged particle is parallel to magnetic field. You know this term. All right, class. I hope you have written it down. So these two cases were easy. Now the third case, but before moving on to the third case, in this third case only, let's study one thing. This is which sign? Inwards, outwards?
Inwards.
Inwards. Only Krishna studies in this batch. Remember when we did those? No, inwards, Fatma, he's right. It will be inwards only. For outwards, we have dot. Remember we did those questions where we practiced different directions there. So dot will be for outwards, cross will be for inwards. Let's see it for this. Fine. So magnetic field is inwards, means magnetic field is going like this into the plane, and charged particle is moving like this. Fine. Now let's say, let me take the charged particle a little down. This is the charged particle. Charged particle is moving in this velocity v. Now I'm telling you the direction. Understand the directions here only. See, right hand, using right hand thumb rule only we'll do it. You have to place your fingers along the direction of motion, means in the direction of velocity. Supposedly, keep on looking at my hand as well as in the screen also. Where is the direction of velocity? Direction of velocity is like this. Had it been pointing towards the left hand side, I would have kept my hand pointing towards the left hand side. So I have to put it towards the right hand side. Now I have to curl it towards the magnetic field. First point, put your fingers along the direction of motion. Direction of motion means along the direction of velocity. And curl your finger towards the magnetic field. Now if I'm keeping my hand like this, if my hand is kept like this, then will I be able to curl it? The magnetic field is where? Magnetic field is inwards. How can I curl it like this? This curling is not possible. All right. So let me just shift the hand. This is also showing a direction where velocity is pointing towards the right hand side. This is also correct. But this way curling is again not possible. If I keep my hand like this, velocity's direction is same. So definitely this is not the correct case. If I keep my hand like this, now see, velocity's direction is correct. Now when I'm curling it, it is getting curled inwards, mean in this direction. This was the magnetic field. So look at the thumb. Thumb is pointing upwards. Thumb gives you the direction of magnetic field. So force will be in this direction. I'm repeating this. See, velocity was towards the right hand side. So I kept my hand towards the right hand side. All right. So after right hand side, after keeping it at the correct position, whether it is your right hand side, left hand side, upwards, downwards, be it any position, what you have to do, you have to curl your fingers towards the magnetic field. So when I kept my hand like this, then only I was able to curl my fingers towards the magnetic field. Otherwise, in different direction, even if it is kept like this way you cannot curl it. So curling was possible in this. So I kept my hand like this. Had it been something else, had the direction of magnetic field would have been something else, then I would have shifted it. So then curl your fingers towards magnetic field. I have to curl it where? I have to curl it inwards, as the magnetic field was inwards. This was inwards. Thumb was pointing upwards. That gave the direction of magnetic force. Is this clear to all of you? If it's
Teacher, can
clear,
you explain once more?
I'll explain. See, Atif and rest others also. You have to keep your fingers along the direction of velocity. So when I kept it like this, or if I keep it like this, or if I keep it like this, or if I keep it like this, all the four are correct. All the four are pointing towards the right hand side, giving the direction of velocity. Agreed, Atif?
Yes.
All right. But I had to, among these, I had to choose the direction where I could curl my fingers inwards, because magnetic field is pointing inwards. So if I kept like this, if I would have kept it like this way curling wasn't possible. Had it been like this, curling wasn't possible. Even if it is kept like this, then also curling backwards is not possible. Only curling was possible if the fingers are kept like this, in this. My palm is pointing towards the screen and the finger is getting curled. So thumb gives the direction of magnetic force. Thumb is pointing where? Thumb is pointing upwards. So force was upwards. Now clear, Atif?
Yes, teacher.
Okay, it will get clearer. You do this. Now, all of you try this. This is the direction of velocity. Magnetic field is inside. Quickly write me in the chat box, all of you. Try it yourself. It can be wrong. Never mind. I'll do it again for you. But just try it once and let me know in the chat box right now what is your answer coming. Yes, Hanifa has answered first and she is correct. Right, Hanifa. Others also, only Hanifa has answered. Shara, are you using your right hand? Just check Sarah once again. Yes, Krishna. So you can write it as left, right also, right? Others also respond. Atif, Fatima, who all are here? Hibba, Huzefa, Kulsum. Yes. Hamza is right. Atif is also right. See, velocities where now? Velocities like this, pointing upwards. Now I have to curl my fingers inwards. Again, this is not possible. If I keep my right hand like this, now this is pointing along the direction of velocity. If I keep my hand parallel to the screen, just see, is my hand parallel to the velocity? I have kept it correctly. Now I have to curl the fingers along where I have to curl it along the magnetic field, towards magnetic field. If I curl it towards magnetic field, this is which direction? Left hand side. Left hand side, or Krishna said minus I cap, both are right. This is right. Now try this one. So all those who have answered correctly, Fatima, Hamza, Krishna, Atif, Sara, Kulsum, Hanifa. Good. So all of you, I think now are able to use this rule for calculation of magnetic force. This will be downwards. See, for those who are not able to understand, velocity is in this direction, pointing towards the left hand side, curling the fingers towards inwards, leads the thumb downwards. Last case. Tell it for this one also. Only this side is left. This one. So correct answers who all have given: Atif, Kulsum, Fatima, Hanifa, Hamza, Sara, and Krishna. Hiba. Good. Hiba is also correct. It will be along the right hand side. See, you have to keep your hand like this, pointing downwards. This is the direction of velocity. So velocity is like this, and I curl my fingers like this. Thumb is pointing where? Towards the right hand side. This gives the direction. Is it clear to you, Josefa? Are the directions clear, Josefa? Because you haven't answered single one. Clear? Fine. So this is the direction of force. Now, a little concept we'll be using from your class 11th. As I've told you, some things get related, like work energy theorem got related. One more thing. You must have done uniform circular motion. Whoever must have taught you, the teacher would have definitely mentioned uniform circular motion. So, can you name that force that acts along the center of, in the case of uniform circular motion?
Centripetal force.
Yes, that's right. It's the centripetal force. Somebody else, Josefa, centrifugal forces that acts outwards. Centripetal force acts towards the center along the radius. Along the radius towards the center. Remember it for centripetal force. And opposite will become definitely for centrifugal force, outward one that is applied. Fine. So if you look at carefully, now the third case is actually what? Why did we learn this? Firstly, let me write the direction, rules for direction. You have to place your fingers along the direction of motion, along the direction of motion. Basically, it means velocity. Just look at the direction of velocity. Secondly, you have to curl your fingers towards magnetic field. And then lastly, the thumb gives direction of magnetic force. These are the rules for it. Now, what was our actually case 3 was? Case 3 basically was that if particle is perpendicular magnetic force. First, it was parallel, force was 0. Second, it was anti-parallel, force was 0. Third, if the particle is perpendicular to magnetic field. See, in this case, obviously, sine 90 is not 0, so your answer definitely won't be 0. Some values will be there. So, what will be that value? Firstly, if these are the magnetic fields, let's say these are pointing inwards. These are the magnetic field pointing inwards. Now the path of, as you can see, we have taken broadly 4 paths. First part here, second part here, third part here. If you look it closely, at every point, if you join all the dots, that becomes a circle. So basically, this was a circular motion only. At 4 random points, I had made you calculate the direction of force, but actually, it was, if you join all the charged particles dot by dot, dot by dot, dot by dot, that completes a whole circle. So here in this case, the motion of the circle is in a circular manner. It was like from here, from here, from here, from here, you had to calculate the charge. So all these are basically, let's say this is the direction of motion of charge, velocity, v it is moving. And what did we observe? We observed that the force was acting at every point, it will act along the center only. Did you notice this? This will be the magnetic force. So if you look here, all the forces actually pointing towards the center. For individual cases, it was downwards, minus I cap, plus I cap, or anywhere, but actually for all the forces, if you see, all are pointing towards the center. So it means that was a circular motion of the charge. So this basically is what? This is a centripetal force. So your magnetic field is actually providing the required necessary centripetal force. If you people have done it in detail, centripetal force is actually not a force. Centripetal force is provided by other forces, like in some cases in your gravitational lesson, especially this question comes in your 11th class, that gravitational force is providing the necessary centripetal force. So here also magnetic field provides the necessary centripetal force. Just wait for 2 minutes and note it down till here first. All right, I was saying that the necessary centripetal force that is being provided by the magnetic force. So, as you people have earlier also heard of, that some other force provides the necessary centripetal force, because centripetal force by itself is not a force. Though magnitude is calculated, but magnitude, it's not actually a physical force. It basically, that force is provided by some other forces. So in your laws of motion also, frictional force sometimes provides the necessary centripetal force while turning of vehicles on the road, when the turning point is there on roads. Similarly, in this case, why are we able to conclude that this provides a necessary centripetal force? Reason is that because it is acting along the center, along the radius towards the center at every point. I'll write it down. Few things let us revise for circular motion. When you have uniform circular motion, here if circular motion is being covered, R is the radius. Along this radius, a necessary centripetal force has been provided. So direction of the centripetal force, is along the radius. It's just a recap for all those who have forgotten this from class 11. And towards the center. Along the radius towards the center. So you will be able to do it. But this is not a tough topic. You will be able to easily relate it. And the best part of this is that this comes a lot and it's easy to score. So you people will be able to handle it. But it is important. This portion, this third case is very important from your numerical point of view. Theoretical questions, all I have told you. So this is uniform circular motion. Magnitude of centripetal force is given by mv square divided by r, which can also be written as m omega square r. Remember, where m is the mass of the particle, this is the mass of the particle. V is the velocity, R is the radius, omega is the angular velocity. And one more relation between omega and velocity is omega is equal to V divided by R, because omega also we have to calculate. So remember the direction. This is just a recap. Make it as a note point. Uniform circular motion. This won't be directly asked. It will be indirectly given in your exam. Now, what is the angle now? QVB, QV cross B is what? It is the magnetic force. So theta will be 90 degree. Why? We are taking the case where particle is perpendicular to magnetic field. So angle becomes 90 degree. So FB becomes QVB. This much. Fine. Now, centripetal force is what? mv square divided by r. What do we see? That the necessary centripetal force is provided by magnetic force. So I can equate both these equations. So QVB is equal to mv square divided by r. QVB is equal to mv square divided by r. 1v gets cancelled. From here, remember all the formula. This is mv, r will be equal to qb divided by mv divided by qb. This will be equal to what? This will be the formula of the radius of circular path. Radius of circular path. Now, what all things are asked? Among all the things that are asked, radius is the first one. Secondly, you have time period. So general formula of time period is what? Time period is distance divided by time. For a circular motion, if radius is r, time period will be what? 2 pi r divided by the velocity. Velocity from the above relation you can find out. See what will be velocity. From here, velocity will be equal to QRB divided by m. This will be the formula of velocity. So put in the formula of velocity here in case of time period. QRB divided by m. So put it here. This becomes what? This becomes QRB. M will go up. RR gets cancelled. Time period is 2 pi m divided by QB. Can anyone tell me what will be the value of frequency?
QB by 2 pi m.
Yes, Arthur, right. See, frequency and time period both have this relation. Frequency is 1 by time period, or time period is 1 by frequency. Both are just reciprocal of each other. So if time period we know, frequency will directly be QB divided by 2 pi m. One more thing, omega. Velocity was what? Velocity was QRB divided by m. And omega is V divided by R. So RR gets cancelled. Omega will be equal to QB divided by m. This becomes the formula for, this is the formula for angular velocity. This is angular velocity, that is frequency. And what all things are left? Yes, one more important, very important thing is left. That is your kinetic energy. This is half mv square. Now remember one thing before I tell you about this kinetic energy. This topic, as I have been telling you continuously, this topic is important. But this topic is very easy to score because questions are based on that similar pattern. One question we'll do in the class also. That ratio question comes. That ratio question is common. You have to do what? You have to just find out the formula. Once you have found all the formula, all these formula, then you can directly use it as in the numerical. Now, what type of questions come in your board exams as well as in your entrances? This is important from your entrances point of view as well. For those especially who will be appearing for a NEET exam, the medical entrance that happens. So especially in NEET exam, this question is so common from your previous years. You can easily find it out that this water will be the value of kinetic energy. You will get it as q square b square r square divided by 2, and that you will see it. You will see what is the value of kinetic energy that you're getting. But that question is so common, directly in the option you have to choose it. Or this is asked in your JE also. This question is asked a lot, that how is time period dependent on the radius? So from the formula you can see time period is independent of the radius. Time period is not actually depending on the radius. R got cancelled, so 2 pi m divided by qb. So time period is independent of the radius. This question can come. So all these questions are possible in your objective exam. For your subjective 12th class board examination, the CBSE or any other board exam, what kind of question comes is that either it will mention you that perpendicular is the relation, is the angle, and find out the time period. So you just have to put in the value for frequency and calculate the formula base. If it comes from derivation point of view, it will ask you to calculate the kinetic energy, time period, or any quantity. But how will you write it in such a way not to lose marks? If it is for 1 marker, you can just directly write this step. What I'll show you, kinetic energy is, see, kinetic, if it comes for 1 marker, you can directly show it like this: half mv square. Velocity is qrb divided by m. So therefore kinetic energy will be half m v square will be q square r square b square divided by m square. Gets cancelled. Kinetic energy is basically q square r square b square divided by 2m. If it's a 1 marker, you will get the question. But if it comes in 2 marker or 3 marker, then you cannot use this directly. You have to draw it in the form of a circle. From here, you have to write it. You have to write this part, not this part, this was your revision, this part, that B and V are perpendicular. That's why the necessary centripetal force will be provided. So using this relation, QVB is equal to mv square by r, calculate velocity from here. Till here, you have to write it. And from here, you can show that velocity, since velocity is this, therefore kinetic energy will be this, or time period will be this, whatever is asked. Like this, you have to give a proper answer for your 12th board exam. Clear? Is this portion getting clear to all of you or not? Yes,
Yes,
class? Others?
Yes, ma'am.
Fatima, both the Fatima, Munir and Ansari. Clear to both of you? And what about you, Fatima, Munir? Because this is a very easy scoring topic and this is very important. So it's better if you people learn all these and do the steps, because it's very scoring, and from both point of view. After your 12th class entrances, whatever entrances you have to appear for, and from your board exam it is. So this was the third case which was important, and formula do come from it. So do one thing, note it down. For all those who have understood, you can also note it down. For all those who will be facing difficulty, you can stop in between and ask me. We'll do a numerical, how that ratio numerical comes. That ratio numerical is common, and that is set pattern. So we'll be doing a previous year question. So note down all these things first. See, for this question, if you require this data, no, you can use this data is not a part of question. This you have to remember on your own. So right now I'm telling you mass of proton if it is empty, then for a deuteron that becomes the mass of deuteron becomes twice that mass of a proton, and mass of the alpha particle becomes 4 times the mass of a proton. Then we have the charge that will be used to charge on a proton is E, the electronic charge which we had discussed earlier in the first lessons, 1.6 into 10 to the power minus 19. And the charge on a deuteron is also E. Whereas the charge on an alpha particle, this is twice the electronic charge. So this data, this is not, again I'm telling you, this is not a part of the question. This is the data that I have given to you so that you can at least try the first part. So same velocity, using the formula of velocity, using wherever you think you can use, find out the ratio of radii. So you know the formula of radii, that is mv divided by qb. So put velocity same, magnetic field will be the same because it's a uniform magnetic field. Just see the ratio what it's coming. Yes, answers class, at least for the first part. Just take the velocity same. Magnetic field will also be the same. So you have to find out the ratio of all the three. Most of the things will get cancelled only, you know. Instead of MD, put it as 2MP. Put it in one standard so that all these can be cancelled. Okay, Atif has answered. Others also, only Atif has given his answer. Atif, it will be Hanifa, 3 are there. Yes, Atif. Your answer is right. Hanifa, this is the ratio between what? Tell the ratio between MP, MD, not MP, it means RP, RD, R alpha. So 3 will be there. I mean 1 is to, 2 is to, 3 is to, 4 is to, 5 is to, in this way. RD.
Okay, I'll just do that.
Alright, Hanifa, just try it once again. Now, Krishna, ratio. You have to find out the ratio of all the 3. Directly cancel it if you're not able to do it. Okay, all these 3, Atif, Hanifa, Krishna, and others also. Submit your, just show me your calculation, send your sheet on WhatsApp. Krishna, on the group you're added, no, just send your calculations. And Atif, you also. Just take a normal picture and just send it. Yes, I didn't receive your solution. This is who's only Krishna. Others also, Atif, you also did it. Kulsum, no. Hanifa was also trying. Just show your solution. Krishna, the thing is that you're doing it correctly. If had it been 2 ratios, then this answer would have been valid. You have to calculate the ratio between all the 3. So no more solutions coming. Should I discuss it then? Just keep it simultaneously. Method is right. Method that you have done, that is correct. Slight error in your answer, Krishna. His answer is right. Atif, are you there in the class? Atif's answer was right. Atif?
1 minute.
Let's discuss it then. See, what was the formula of radius? Radius formula is mv divided by qb. So firstly, velocity is same for the first part. First part has same velocity. It means in this formula of radius, velocity will be the same and the magnetic field is same. So only m and q will vary. So you have Rp is to Rd is to R alpha. This will be what? This can be written as Mp, mass of proton, multiplied by velocity of proton divided by charge on proton multiplied by the magnetic field in which proton is to mass on the deuteron, velocity of the deuteron, charge of the deuteron, and the magnetic field. This is the right answer. Yes, correct. Your solution, this only he has done correctly. So this will be what? This is to mass of alpha particle, velocity of alpha particle, charge on the alpha particle, and magnetic field of the alpha particle. Now this data, according to this data, if you put in standard, if you take the standard as the proton, so what can happen? You can convert everything in terms of proton. So mass of proton, velocity is the same, charge on proton is E, magnetic field will be B. Is 2. Mass on deuteron, this is twice the mass of a proton. Velocity will be the same. Charge will be the same, and B is the magnetic field, is 2. 4 times the mass of proton is the mass of an alpha particle. Velocity will be V. Charge will be twice. This will be magnetic. So velocity gets cancelled. BE gets cancelled. MP gets cancelled, and 2 ones, 2 twice is 4. So your ratio of RP is to RD is to R alpha becomes what? 1 is to 2 is to. Like this you had to do. Now, just making you recall, second part says same momentum. Formula of momentum is mass into velocity. Note down the solution of the first part. Now try the second part, same momentum. So MV both will be the same. So see what's your answer. What's the answer you people are getting? See the change that will come in the second part. The change that will come in the second part will be that instead of taking mass as twice or 4 times, you just have to take all the masses also same along with the same velocity for the second part. So answer is right. 1 is 2, 1 is 2, 1 by 2. 0.5 is 1 by 2. Right. See from here also you can see. This will be, so RP is to RD is to R alpha. 1 is to 1 is to 0.5. Yes, sir. Right. That will be, second one will be half. See how the formula will be MP into VP divided by the charge on the proton into the magnetic field is to mass on the deuteron, velocity of the deuteron, charge on the deuteron, and the magnetic field. Mass of the alpha particle, velocity of the alpha particle, charge of the alpha particle, and the magnetic field. All these things. Right? Now we have to substitute the value. What would be the, see, mass and velocity, product of mass and velocity is momentum, that is same. So it means this term, and this term, the third term, all these are same. That is MV divided by. Josefa, what will be the charge that I should write over here? The magnetic field will also be same. All these things will remain same. mv by b, mv by b. Therefore, what will be the charge that I should write for a proton? What's the charge on a proton? Josefa Ahmed. After the question, I've made you write 2 lines as well. Just look in from there, Josefa. Charge on a proton is same as that of the electron. The charge on proton will be E. What about charge on deuteron, Josefa? Now can you try the charge on a deuteron? Hamza, can you try?
Ma'am, it will be E.
It will be E. And Hamza, tell it for alpha also.
Ma'am, 2E.
These data I have made you write. E and 2. Yes, so M, V, E, B, all the 4 terms get cancelled. From here only 1 is to 1 is to 1 by 2 is left. That's the answer. So 1 is to 1 is to half. Sarah, right? Note down this part as well. Third part said what? Same? Something was same. That was potential difference. Same kinetic energy. Kinetic energy, this way we can do. You can note down the second part later on. Kinetic energy was what? Q square from this formula. We did it now, remember? Q square R square B square divided by 2m. Here we did it. Q square R square B square divided by 2m. The formula of kinetic energy. So formula of kinetic energy is what? Q square R square B square divided by 2m. From here, value of R will be what? 2m into kinetic energy divided by q square b square and whole term under root because this was r square. So since both of them are square, so this can be written as qb and this becomes 2m into k. This is the formula of radius. Now using this formula, mass you know, charge you know, magnetic field and kinetic energy, both of them are same. So from here you have to find out the ratio now. So what will be the ratio? Rp is to Rd is to R alpha. Now under root for the proton. Fatima, can you answer for the proton? What should I write? All the things using this formula. This one.
2 MP.
MP. Let's say kinetic energy is Ke divided by
E square.
E square. No, from here. See, root Q square B square under root becomes QB only. So that's why I've written it QB. So here it will be
EB.
EB. Correct. That will be EB. This is 2. Kulsum, can you try this for the deuteron? Krishna, the answer that you have submitted is for which one? This you have written something. This is for this answer.
Yes, ma'am. I missed something. I'll listen again.
Yes, where is Kulsum? Yes, Kulsum, what will be the formula for deuteron? The way Fatima answered it for proton, I'm asking you for deuteron. Atif also sent his answer, no? Kulsum, are you not able to unmute yourself? All right, just type it then. See, root will be there. Instead of mass of proton, 2 will be there. Mass of proton, this becomes what? You have the mass of the deuteron. So that is also, that is twice of mass of proton. Then the kinetic energy, root 2 into m. Mass of deuteron will be written as 2 mp. Rest of the things are correct. Alright, also. Mass of the deuteron will be written as 2 mp divided by ED, correct. Sarah, can you answer the last one for alpha particle? Sarah?
2 into 4 MP into kinetic energy by 2E into D.
Perfect. Right. So see, from here you people can observe that root 2 into kinetic energy divided by EB, all these things are common. So what will be left from here if root 2 and all these things get cancelled? From here, root 1, basically 1 will be left. From here, root 2 will be left. And from here, what will get cancelled? 1, 2 is there in the denominator. That will be 1 is 2, root 2 is 2, 1, no?
Ma'am, root will be cancelled, right?
Root 2 will be cancelled, no? So this root 2 gets cancelled. So from here, root 2 will be left. So this is right till here. And from here, this becomes, okay, this was 2. This is under root 2. This is under of these one. One is 2, 2 is 2, 4. See, from here, root 2 will also get cancelled. 2 divided by 2 will be left. So 1 will be left, no? See, it won't. From here, this root 2 gets cancelled and root 4 is left. Root 4 divided by 2 is 1 only, no? Just check. Who was saying, Krishna? Just cross check it. Others, Atif, your answer was what? Your answer it was root 2 is 2, 2 is 2, root 2. So if you divide the whole term by root 2, this will be the answer. Same answer, Atif, right? It's just that this is the rationalized form of your answer, no?
Yes, teacher.
This will be the answer. Rest of the things get cancelled and this much will be left. For the fourth part also, if it is same kinetic and same potential difference. See, one relation that we'll be doing in your second term, in your modern physics, you have a relation there. So in that you have, we'll be doing it. And I think in your chemistry also, quantum physics was included in your structure of atom, I believe. I don't know now is it included or not, or whether it has been deleted. But that quantum physics will be repeated in your second term. You have atoms whole chapter again. There you have different formula, and then dual nature lesson is there. Then dual nature deals with this only, matter nature and particle nature. So kinetic energy is given by the charge multiplied by the potential difference. So we can just in this radius formula, no, where under root 2 m ke divided by qb is written, there instead we can write the formula of radius as 2 m. Instead of kinetic energy, we can write it as EV divided by, not EV exactly, this is basically charge into potential. I'll write it as charge only because other charges are also there. No? This is E. So this will be QV divided by Q. Now you can find the formula of RP is to RD is to R alpha. That becomes what? Under root 2 MP EV divided by EB. This is to under root 2 into twice of mass of proton because this is the mass of deuteron. And charge on its remain the same. So here it will be the same. is 2. Now what is left? 2 into, this is twice the mass of proton. This is 4 times the mass of proton, and the charge is also doubled here. So that becomes 2e. Now let's see what all things can be cancelled. So majorly from here you can see root 2, this whole term will get cancelled. From here, this, if we write this as 1, because this whole term will get cancelled. So root 2 will be left from here again. And this time, since 2e is also included above, so from here this will be 4 into 2, that becomes root 8, or you can write it as 2 root 2 also, 2 root 2 divided by 2. So that here this will be 1 is 2 root 2 is 2. Here, so it's just the calculations are easier. Once you do it, no, everything gets cancelled. Just write it down. In whichever part you have issue, tell me the part number. I'll repeat everything. So velocity one, you have noted it down. Which one you had to write it? Momentum you have written from kinetic energy. No, if anyone who wants to write the above portion, let me know. From kinetic energy, I'm keeping the page. And then now see, so this has been covered. So this was the third case. Now the fourth case is left. Fourth case is very easy. Fourth case is very, very easy. You just have to remember 2 lines in it and draw the figure. Whole 3 number is provided. Major important portion is this from all aspects. And you people will be able to do it if you just look at the formula. No, once just write it. After the class, just practice this once. You'll be able to do it. All right. Now see the last case. First case, what did we do? Angle was 0 degree. Second case, what did we do? Angle was 180 degree. Third case that we did was angle was 90 degree. Fourth part says that if the particle is at an angle But this angle this time, this is not equal to 0 degree. This angle, this is not equal to 180 degree. This theta, this angle is not equal to 90 degree. All these three cases are not there. So how will you, what will be basically the path of the charged particle? So let's say let's just take it at a random angle. These are the magnetic field lines. Magnetic field is there. This is the charged particle at a random angle V. So if this is theta, the angle with which the vector quantity makes the angle with that axis, what comes? Cos or sine? What will come here in for this axis? If I resolve
Cos.
velocity, cos. So here it becomes V cos theta. This is known as V parallel. And the above question, this becomes V sine theta, which is known as V perpendicular. Now, motion of charge particle. This is the case of velocity. See, what will be the role of velocities? Two velocities are there. The parallel velocity means this parallel component, V parallel. It will move charge in a straight line. While V perpendicular will do what? This kind of motion, this will be provided by V perpendicular. Whereas this motion, what is this motion? Circular motion. So this moves particle in a circle, circular motion. So right now what is happening? Either of them is not working. Both of them are simultaneously working. V parallel is also there. V perpendicular is also there. So a motion where perpendicular straight line is also there, then that is interrupted by a circular line. Then again a straight line, which is again interrupted by a circular line. Means basically this motion combined with this. This. So it's like this, then a curve, then V parallel is acting, then V perpendicular, V parallel, V perpendicular. Can anyone name this?
Solenoid.
Can anyone name this motion? Solenoid? No, not solenoid. Solenoid is not a motion, no. This is helical. This part, like this, like a spring. So this basically helical path will be helical. So if both of them are combined, path will be helical. Yes, Joseph, a helical motion. So basically, what will be the path of this charged particle? V parallel, V perpendicular. Then V parallel acted, V perpendicular, V parallel. Similarly, this it will keep on. This was your fourth case, and this comes only in your theory questions. Yes, if it comes for your numericals, if by chance, because question can come in any manner, we cannot take guarantee of any question. If it comes, then for all these formula, all of these, just use the perpendicular component. The rest of the things will be the same. From here, you can get your answers. Note down the source. In the next class, we'll be starting with what is actually the Lorentz force. So that is also not tough. Electric field basically gets added. So just revise electric field once and come. And from this, I have told you all the detail about all the parts, which one is important, which one is the least important, from where the numericals come. Fine, so just note it down. Just text me done in the chat box so that I can stop the class. I'll stop here. This is the last topic. Your time is almost. Done. Others, we've also completed. All right. So all those who have done, I'm stopping here. Let's meet in the next class. We just have to take 2 to 3 more classes of this, that this chapter will end. Fine? Oh, take care.
Thank you, teacher. Bye.
Thank you, ma'am.
All right, bye.
Thank you.
Thank you, teacher.